Here I want to solve the system of equations. Because I have both x squareds and y squareds, I'm going to try using the addition rule by multiplying my top equation by -3 and my bottom equation by 2 so that the x's will drop out, because I'll have -6x squared plus 15y squared equals +6 for my new top equation. My bottom equation will be 6x squared plus 4y squared equals 70. So that when I add these, I can see that the x squareds drop out, and what I have is 19y squared equals 76. So since 19y squared equals 76, I can divide both sides by 19 to get y squared equals 4. Taking the square root then of both sides, I'll have y equals, I have to remember it's positive and negative square root of 4, which is positive and -2. So I have two solutions for y. Now I can go back to either of my original equations. Let's say 2x squared minus 5y squared equals -2. And if I substitute a y in, I will get an x value. So I could have 2x squared minus 5 times 2 squared equals -2. 2x squared minus 2 squared is 4 times 5 is 20 equals -2. 2x squared equals 18. When I add 20 to the other side, x squared equals 18 divided by 2 is 9. Taking the square root of both sides, I get x equals plus and minus 3. So that gives me x equals 3 when y equals 2, and x equals -3 when y equals 2. If I try the same thing with y equals -2, what you should notice is when I square the -2, I again get 4 times 5, which is again 20. Which is going to take me right back to this point because I'm squaring the negative just like I squared the positive. So solving from this point down, I'm going to get the same two solutions. So what that means is that x also equals 3 when y is -2, and it also can equal -3 when y is -2. So whether I have y equals 2 or -2, I get the same two solutions for x. So that means x is 3 when y is 2, and x is also 3 when y is -2. And x is -3 when y is 2, and x is also -3 when y is -2, so that I have 4 solutions for this system.